Hey guys, how's it going? So easy one today. Well, not easy. I'm sorry, I shouldn't say that. Pretty straightforward one today. As long as you got the skills we've been going over the last few days, this really is. We're only going to add one thing to it today. So we want to talk about square roots with variables. So if I said, what is the square root of x? We can't do anything with that because we don't know what x is, right? But if we think about it, we remember what a square root is, right? Square root is we want to find what number times itself multiplies to make x. Since we don't know what x is, we can't tell what numbers would multiply to make it, what two equal numbers would be that would make it. So there's not anything we can do with something like that. What if I said, what's the square root of x squared? Now, again, let's think about what a square root is. I want to know what number multiplied by itself makes x squared. X squared, by definition, is x times another x. So we do know what number times itself makes x squared is x, right? X times another x makes x squared. Therefore, we can say that the square root of x squared is x. Okay? So we know that this is true because we know that x times x makes x squared. If you think about this with numbers in it, let's think about this. If I said, what's 3 squared and what's the square root of that? Okay? Well, 3 squared becomes 9, and the square root of 9, well, it just brings us right back to 3, right? So these two things really just kind of undo each other. I'll show you guys another one. So let's say we said 5 squared. What's the square root of 5 squared? Well, 5 squared is 25. The square root of 25 is 5. So we just get back to whatever numbers in here. So the same thing here. Square root of x squared is equal to, well, we can't actually put the number in there, but it's going to be the square root of x times x. So we just want one of those things. So whatever we get out here is what we started with here. Okay, so this has a lot to do. You guys, again, should be familiar with this concept because it's an inverse operation, right? How do we undo squares? We use square roots. But what if I said square root of x to the third? Now, this is something that a little bit tricky, right? But let's think about this. Let's think about what is the square root of 3 to the third power? Well, really what that is that's the square root of 27, which we talked about yesterday. And how do we solve this? We can split this into two parts, right? We can say perfect square that goes into 27 is 9, and that's radical 9 times radical 3. So square root of 9 is 3, and so our answer becomes 3 radical 3. Another way of looking at this is what if we kind of got ahead of the game? What if we said that this is really, and this is true, the square root of 3 squared times the square root of 3, right? Right? That's 1, 2, and a 3, right? This 3, this is really to the first power, right? So there's 1, 2 of them there, and a third one there. Well, again, the square and the square roots just undo each other, and we're just left with this radical 3 on the inside, okay? I'm going to show you a shortcut. Don't worry. If this is looking a little bit crazy to you guys, I'm going to show you a very nice shortcut, okay? So, what's the moral of the story? This really becomes radical x squared times radical x, and this we know, okay? This becomes x and x here, okay? X to the fourth, okay, is actually radical x squared times radical x squared. This we know. This is actually x times x, or x squared, right? So here's kind of your rule. Here's kind of your rule. You're going to divide the exponent by 2, okay? So if I said, what is the square root of m to the 8th power? 8 divided by 2 is 4. Just like that, okay? Again, because m to the 4th, think about it, m to the 4th times m to the 4th is m to the 8th, right? 1, 2, 3, 4 times 1, 2, 3, 4. Enter E. Okay. If it's an even number, you're not going to have a remainder. So again, any even number divided by 2. So if I said, what's the square root of q to the 18th power? 18 is an even number. 18 divided by 2 is 9. Q to the 9. Okay, so no big deal there. The only difference we're going to have is what if there's an odd number. Well, odd numbers are not divisible by 2, right? We can't divide an odd number by 2, so we're going to have a remainder. Now, I know we haven't been talking about remainders for a while. So what if I said p to the 5th? Well, what are we going to have? Well, p divided by 5, p to the 5th divided by 2 is going to be 2 with a remainder of 1, right? Right, 5 divided by 2 is 2, and we have a remainder of 1, right? Pretty much since we're only dealing with positive integers here, we're only dealing with numbers like this. Pretty straightforward. What are we going to have? Well, we divided by 2 and we got out 2, and there's only going to be a p left in here that we can't deal with. Okay, so we're going to divide by 2. Your remainder of 1 is going to go in here. The most you're going to have is the remainder of 1 until we get to some of the higher indexes. So if I said, what's z to the 9th? Well, 9 divided by 2 is 4 with a remainder of 1, right? So it's going to be, 4 with a remainder of 1. Okay, so again, if you get an odd number, you can always think of, I'm leaving 1 in there. What's 1 less than this? 8. 8 divided by 4 is 2. 8 divided by 2 is going to be 4. So pick your poison, but pretty much all you need to do is divide by 2. Okay, you can divide by 2, you have a remainder of 1. So let's go over a few of those and some additional things that they can ask you. All right, so let's talk about this. So you have 18s squared. They want the square root of 18s squared. Now, we knew from yesterday we were allowed to split this number up, so we can actually split all of this up. I can say this is radical 18 times radical s squared. Okay. Now, we knew from yesterday that 18 is not a perfect square, but what's a perfect square that goes into 18? 9. So we say this is radical 9 times radical 2, right? 9 times 2 makes 18. And we're just going to bring this s squared down, okay? Well, let's start chunking this off. Well, the square root of 9 is 3. The square root of s squared is s, and the square root of 2 is just going to remain the square root of 2, okay? So again, what do we do? The same thing we did yesterday. We found the square root of 18. That was, 3 radical 2. All that we're adding today is dividing this number by 2. Right? 2 divided by 2 is 1, and that comes out on the outside. No remainder. All right, what if I said 12m to the 6th? They want the square root of 12m to the 6th. Now, again, we can see that this is going to be an even number. 6 divided by 2 is going to be 3. So if you want to get ahead of yourself and throw that right out in the front, that's fine. But for right now, we're going to split this. We're going to say square root of 12 times the square root of m to the 6th. Again, 12 not a perfect square, but what's a perfect square that goes into 12? 4, right? 4 is a perfect square. 4 times 3 makes 12. Okay, we'll bring that one down. Square root of 4 is 2. Square root of m to the 6th is going to be m to the 3rd, and let's leave the radical 3 there. Okay. The disadvantages as to yesterday is you can't just plug this in your calculator, check it. Square root of 75k. Okay. So again, let's split this. Let's split the number, square root of 75, and square root of k. Now, right off the bat, I can't do anything with this. It's just a square root of k, right? I can't, there is no square there. I can't say anything about it. It's just to the first power, okay? So right in here, though, we can split this. What's a perfect square that goes into 75? 25. 25 times 3, 3/4, right? Okay, and let's bring that k down. Well, the square root of 25 is going to be 5, and what am I left with? Radical 3, I can't do anything with that. Radical k, I can't do anything with that. Just put them back together, okay? Put them back together. Remember, this is all multiplication here. We don't have to write the multiplication symbol, but that's all multiplication in the middle. Okay? So again, you can just put these right back together, all right? All right. Radical 125 q to the 10th, all right? Let's split it up. Radical 125 q to the 10th. Well, again, what's a perfect square that goes into 125? 25 does. How many times does it go? 5 times. 5 times 1. 5 times 25 makes 125. Q to the 10th. Square root of 25 is 5. Square root of q to the 10th is going to be q to the 5th. And let's just keep that radical 5 right there. All right. What if they gave you 2 radicals? Okay. Well, again, we're just going to split this up into 3. We say the square root of 64 times the square root of q to the 5th and the square root of r to the 6th. Now, nice, square root of 64 is 8. Okay. Square root of q to the 5th is, again, we're going to divide this number by 2. 5 divided by 2 is 2 with a remainder of 1. R to the 6th divided by 2, well, 6 divided by 2 is going to be 3, right? No remainder. Okay? So what do we have to do, though? Let's put this out here in the front. 8 q to the 2nd, r to the 3rd times radical q. Okay? Again, this one has a remainder of 1, so it gets in here. This has no remainder, right? 6 divided by 2 is just going to be 3. So really, you should never have an exponent other than 1 in here, okay? You might have some numbers, some variables in there, some coefficients rather, but you should never have a remainder greater than 1 because it's either an even number where it's divisible by 2 or it's an odd number where you have a remainder of 1. Okay? So big one, what if I said we have 54 m to the 3rd, n to the 3rd, p to the 7th, okay? So again, all odd numbers here, right? Well, let's break this up. I've got the square root of 54, square root of m to the 3rd, the square root of n to the 3rd, and the square root of p to the 7th. Well, 54 is not a perfect square, but last I checked, 9 goes into 54 6 times, right? If I split this up, 3 divided by 2 is 1 with a remainder of 1. So it's 1 with a remainder of 1. Same thing here, n to the 3rd divided by 3 divided by 2 is 1 with a remainder of 1. And p to the 7th is going to be 3. 7 divided by 2 is going to be 3 with a remainder of 1. Okay? Square root of 9 is 3. Okay, and that's all we can do with this. Okay, so let's take all the ones that are on the outside. M is coming with us, n is coming with us, p to the 3rd is coming with us. What's going underneath the square root? Whatever's left underneath here. I still have, well, this was simplified, right? You're going to have the 6 come, the m come, the n come, and the p come. Okay, and that's it. Okay, so that's pretty much as complicated as we can get. I'll go through a couple more. What if they gave you 6 times radical 50 c to the 4th? Well, again, same thing we were talking about yesterday. It's going to be the same thing. We're just going to multiply by 6 at the end. Okay, so 6 times radical 50 times radical c to the 4th. Again, what are some perfect squares that go into 50? Radical 25 times radical 2. So 6 times this. C to the 4th is going to be c squared, no remainder, right? So it's going to be 6 square root of 25 is 5 times radical 2 times c squared. 6 times 5 is 30. Let's bring the c squared up to the front, and let's leave the radical 2. If you had, all right, I'll give you guys a big one. 10 times the square root of 350, don't freak out, p to the fourth cube. 350, what's the number? What's the perfect square goes in 350? When it's a big number like this, again, it ends in 50, right? You should guys know it's what? 25, right? 25, 50, 75, 100, 125. If you see this pattern will continue, 150, 175, 200. So if it ends in double zeros, 25, 50, or 75, it's divisible by 25. In this case, 350 is going to be square 25 times 14. Okay, so again, you can use your calculator, you break it out, you do 350 divided by 25, find this number. But again, when you get a big number like that, you just start chopping it down. Again, now we get to 14, there's no perfect squares to go 14, we can stop right there. Okay, so we have 10, square root of 25 is going to be 5, square root of 14 is square root of 14, we can't break that down any further. 4 divided by 2 is going to be 2, and the square root of q I can't do anything with. Okay, so 10 times 5 is 50. Let's bring the p squared up front, and let's put everything that's underneath the radicals together. I got 14, and I got a q. Okay, if you can do this, you're fine. If you can do this, you're fine. If you can't do this, I'll give you guys a couple days to catch up. I know it's a little bit tough. Okay, and let's just do one more for good measure. So what if I said 490 s squared t to the third? I want the square root of that. Well, again, 490 should tell me that's 49 times 10, right? I know that 49 is a perfect square. Okay, so let's go ahead and let's break this down. So we square root of 49 times the square root of 10 times the square root of s squared times the square root of t to the third. Square root of 49 is 7. Square root of 10 is just going to be radical 10. Square root of s squared is going to be s, and t to the third, 3 divided by 2 is going to be 1 with the remainder of 1. So let's put together everything on the outside. I got a 7, an s, and a t. And everything that's underneath the radical, a 10 and a t. Listen, if you guys can handle this, you're in very good shape. If you don't, please send me questions, specific questions. Take a screenshot of something they gave you on iXL, and I will gladly answer it for you. Just a quick aside. Just make sure if you're doing that, I got that problem from iXL, by the way. So we figured out this was 7, was it S, T, and I need to do a radical sign. Just make sure you guys have a good feel for the radical sign in the exponents. If you guys are getting wrong answers because of that, let me know and I'll make a video specifically on how to do that. But this should be, so let me put it 10. What did we figure out was? 10 times T. Okay. All right, guys. I'll see you later.